An address signal is routed to follow the signal topology. Here it is to be routed from controller to the memory devices and onto the termination devices. The address signal is manually routed. A dialog is presented and a constrained pin pair is selected and applied. The widen route section can now be inserted by opening the Select Pin Pair dialog and choosing the next constrained pin pair. Note the route width has now changed and the VBP start lead-in has snapped to the width change position. The widened route section can be completed by again opening the Select Pin Pair dialog and choosing the final constrained pin pair. The route pattern can be completed. For quick completion of the routing patterns, a group of routes can be selected between two memory devices and a copy and paste process can be performed. Note VBPs are automatically snapped to the fan-out vias. The differential clock signal is routed in a similar manner by selecting the constrained pin pairs from the dialog. However, when the widened set of pin pairs are selected, it is required to position a new gather point. The start lead-in VBPs will snap at the end of the widened section. The route pattern can be completed. The constrained pin pairs can be confirmed correct by using the pin pair width and spacings reports. With all the DDR3 signals routed, they are interactively lengthened to ensure all skew group constraints are met. The skew group constraints are confirmed as being met. In conclusion to the layout overview, I was able to constrain and route the DDR3 system within the layout application. From the results achieved, the application has provided a mechanism to ensure that the topology, skew, length and impedance balance routing requirements of the DDR3 system were achieved.
Although we've designed to constraints, it's always best to simulate with long data sequences to make sure we haven't missed anything. Maybe there's crosstalk on the clock signal, or maybe we've accidentally routed over a power or ground plane split and compromised the power integrity. Notice how applying topology templates and even plain copy and paste made it much easier to design this circuit with maximum electrical symmetry. DDR3 uses source synchronous logic, and that means maximum electrical symmetry yields maximum performance at the highest clock rates.